Hello and welcome to Hackers Academy Hacking for Beginners course. My name is Tariq and I'm going to be your instructor for this course. This is the prerequisite course to all other trainings at Hackers Academy. Once you understand the concepts and the fundamentals in this course, you're going to be able to move comfortably throughout the other courses and throughout the other trainings at Hackers Academy. You're probably here because you want to learn hacking, but you don't know where to start, you don't know where to begin. There's so much conflicting information out there on what to do and how to begin and what to be experimenting with and what to be reading and so on. So I don't blame you if you're confused, and I also don't blame you if you want to become a hacker. Because our world has been made much better by some brilliant hackers. People like Jobs and Wozniak and Bill Gates, they all started as hackers. And they contributed so much to our world. Imagine if our world today didn't have a Jobs or a Gates or a Wozniak in it. If we didn't have the Apple products or the Microsoft products. These guys started as hackers. So what is a hacker? Did they start by breaking into things and causing havoc and causing damage? This is where we would like to draw a very clear distinction. Because unfortunately, because of the media and what you see in the movies, people have a negative association to the word hacker and hacking. But as a matter of fact, a hacker is simply somebody who has this ferocious curiosity that wants to understand how things work and how things operate, who likes to take things apart and tinker with them and make them better and improve on them. This is what a hacker is. This is how Jobs and Wozniak and Gates started. They just wanted to build things that are better. They wanted to build a better computer. They wanted to build a better operating system. They took what was there. They pulled it apart. They understood exactly how it works and they improved on it. In essence, this is what a hacker is. So if you're someone with this curiosity, if you're someone who wants to understand how things work, who wants to break things apart and who wants to improve upon things, if this is the attitude you're bringing into this course, then brilliant. Because this is exactly what is required for you to become an excellent hacker. And who knows, maybe you're going to be the next Jobs or the next Gates. So let's clarify exactly what do we mean by hacking. And who better to clarify this than one of the most brilliant hackers of our time? Did you know that the founder of Facebook is a hacker? These are some actual codes that were written by him. And this is what he says. In reality, hacking just means building something quickly or testing the boundaries of what can be done. It's not about causing damage or being malicious or causing havoc. This is the misconception about hacking. He says hacking is also an inherently hands-on and active discipline. Absolutely. You cannot be learning hacking by just reading books and watching videos. Throughout this course, you're going to be experiencing firsthand some hacking tools and how does it feel to break into a remote system. And the hacker culture is also extremely open. It's open to sharing. It's open to giving. And you're going to experience this at the Hackers Academy forums. You're going to see what exactly we mean when we talk about being open. At Facebook, Mark says that we have cultivated a unique culture and management approach that we call the hacker way. They are so proud of being hackers, so proud of making the world a better place, so proud of improving on the way we communicate and in the way that we network, such that they have the hacker way at Facebook. At Hackers Academy, we also have the Hackers Academy way. At Hackers Academy, we highly encourage you to master the basics. We all heard of the saying that says, you cannot build a tall building on weak foundations. This is the foundational course. This is the course that you want to have a solid grip on. You want to be able to understand all these concepts in this course and be comfortable with everything we're talking about and explaining. Once you master these basics, then you can move on. And how do you master these basics? By practicing, and practicing. Mark said that hacking is a hands-on and active discipline. Unless you practice, you're not going to understand the full extent of the concepts that we're going to be sharing with you in this course. Just like any discipline, hacking requires practice. If you want to learn swimming, or if you want to learn driving or flying a plane, you could read 1,000,000 books on these topics, but unless you actually go and practice, you're not going to be able to swim or drive or fly. You could read 1,000,000 books and watch 1,000,000 videos on hacking, but unless you go and practice, you cannot understand the full extent of what we're talking about. Mind you have to do this legally always. And throughout this course, we're going to be teaching you how to set up your own lab so you can practice whenever you want, however you want. The second step of the Hackers Academy way is to share knowledge. Like Mark said, the hacker culture is extremely open. And once you understand the practicalities of what you're learning, share your knowledge. Go back to the Hackers Academy forums and answer questions. Some of your colleagues might have questions, might be stuck somewhere. Answer the questions if you know the answer. If you've read an article that you found interesting, share it. If you discovered a tool that you found interesting, share it. Be open and share your knowledge. Because the more you share, the more you learn, the more your knowledge will expand. And when you're comfortable with the concepts that you've learned, it is time to learn some more. It's time to start building on top of these foundations. The ethical hacking world is so vast. You could be specializing in so many different things. You could be specializing in network hacking, operating system hacking, wireless network hacking, web application hacking, mobile application hacking. It just doesn't end. And this is the beauty of the world of ethical hacking. There is so much to discover. But you can only do that once you've built a solid foundation, you understood the practicalities of it, and you start then expanding your knowledge. And last but not least, repeat. You practice, spread and share the knowledge, and then learn some more. And this is how you become an exceptional hacker. So where do I begin? This is the biggest question that you probably are asking yourself right now. And this is why you're here. This is why you're watching this video. Before I tell you where to begin, let me address some of the biggest misconceptions that are out there. You ask this question to 10 people and you would have 10 different answers, each more confusing than the other. Unfortunately, there's a lot of information out there that creates more confusion than clarity. And one of the most confusing answers is that for you to begin to learn hacking, you have to learn programming and scripting and this language and that language. The truth of the matter is, if you're just beginning, you've never done any kind of hacking before, you're an absolute beginner and you want to begin somewhere, programming and scripting can wait. Now, let me be very clear on this, because I know some people are going to come back to me and they're going to be so upset about this, saying, how can you say that? How can you become a hacker and not know programming and scripting? That's not what I'm saying. If you think that Mark created Facebook without knowing how to program, you would be very wrong. He's an exceptional programmer, and this is why he's an exceptional hacker. All I'm saying is, for you to begin now, programming and scripting can wait. Later on, you absolutely, definitely must learn how to program and how to script. Without it, you cannot be a great hacker. But for now, to begin, you do not need that. You're going to see that by the end of this course, you'll break into a remote system without writing a single line of code and without reading a single line of code. Once you have the foundations, once you understand all this, then later on, go knock yourself out. Learn as many programming languages as you want and as many scripting languages as you want. But for now, there's no need to put off learning hacking and go spend 2, 3, or 4 months trying to learn a programming language. Then you'll have somebody who says, you need to learn how to use these tools and those tools and 100 other tools. As somebody who's new to the world of ethical hacking, you might be thinking that learning as many tools as you can is the way forward. Unfortunately, if you do not understand how these tools work or what do they do and what are they based on, you might be ending up causing more damage. And there's a very good chance that you're not going to get the result that you want out of these tools. You need to understand how tools work and how you can tinker it and sometimes even modify it so you can get what you want out of it. Luckily for us though, as you progress throughout this course, you're going to find out that most of the hacking tools fall under a very limited number of categories. So for example, you are going to discover that some tools fall under the category of port scanning, vulnerability scanning, online password attacks, offline password cracking, and so on. There might be dozens of tools under each category, but the important thing to get out of this is that you understand exactly what each category means. So when we're talking about port scanning, for example, what is port scanning and how does it work? Then you can move on to picking and choosing the tool that you prefer over the other tools. By the way, if you don't know what port scanning is, don't worry, you're going to be discovering this later on. Then you'll have some people that say, you cannot become a hacker unless you learn this operating system or that operating system. If you don't know Linux, you're not a hacker. If you don't know Unix, you're not a hacker. Well, Again, guys, remember here we're talking about beginning, where to begin. This is the first step into the world of ethical hacking. And I want to keep it as simplified as possible for you. Yes, later on you definitely must learn Linux and Unix. If you're taking this as a step into a career of ethical hacking, there's a very good chance that later on when you're doing security assessments, you are going to come across targets that are Linux and Unix based. And if you don't know your way around these operating systems, even if you break into that system, your security assessment will come to a stop and you wouldn't be able to progress any further if you're not comfortable with these operating systems. For now though, we want to keep things simple. So from your Windows machine, you're going to be doing everything in this course. You're going to be installing all the tools and breaking into a remote system without having the need to learn any Linux commands. By the way, the target that we have set up for you is a Linux box, so you are going to be compromising a Linux machine. We'll be teaching you very few commands that you're going to be needing, but that's about it. If you want to explore Linux later on, we have a complete course for you. You'll also have some opinionated people that say, you have to read these books and those books, and without these books you cannot even begin to learn hacking. I admit, very proudly, that I am a bookworm. I love reading and consuming books. When I was doing my master's thesis, I probably read around 25 to 30 books in the span of 3 months. And I still consume books ferociously. I love to read. Having said that, remember that we said hacking is a hands-on and active discipline. And what we aim to do with this course is to get you diving into the practice exercises as soon as possible. Reading books is all good and well, but unless you practice, there is no moving forward. Then you'll have some groups that will say, for you to become a hacker, you have to fight authority and fight the mainstream. I'm not going to dwell too much on this. If this is why you're here, you're in the wrong place. We at Hackers Academy do not advocate this. As a matter of fact, we strongly oppose this. You're watching this video because you're probably a student at school or university and you're wanting to expand your knowledge, or you're a professional with a job who's looking to expand his skill set. Either way, fighting authority and fighting the mainstream is going to get you in trouble and is unethical. At Hackers Academy, we aim to be the best ethical hackers that we can be. So, having said all that, how do you approach this course? You'll notice that this course is divided into easy to digest bite sizes, small easy to follow sections. Make sure you understand every section before you move on, because the new sections build up on the previous ones. And unless you fully and completely understand the previous sections, you might find it difficult moving forward. To help you fully understand these sections, we've included missions or practical exercises at the end of every section. Make sure you complete these missions. Once you complete them, record your success. Take notes, take screenshots, write a small report. Whatever you do, make sure that you record your success because there's a very valuable prize waiting for you. I'm going to give you a small hint on what it is. We at Hackers Academy believe in rewarding excellent students that work hard. We do not believe that an excellent student who excelled at a course should be paying the same amount for the next course as the average student. So does that give you a small idea of what to expect? Good. So make sure you record your success. Send it to us by the end of every section or by the end of the course. We're going to review it and go over it. And based on how well you performed, you are going to be getting a valuable prize moving into the next course. Now, I know some of you talking about missions and exercises are a little bit concerned, thinking, what if I got stuck? Here's what you do if you get stuck. Replay the section video at least 2 to 3 times. There are some times when the core concept of the video would be hanging on a small sentence or a small paragraph that you might have missed for one reason or another. Maybe I'm talking too fast, maybe it's my accent, whatever it is. If you missed it, double check, make sure that you rewind the video, play it a couple of times, just to make sure that you went through the whole material. If that does not help, do a bit of online search. Start getting used to finding answers on your own. Be curious, do some research, look around, ask some questions. If that does not help, if you still don't find an answer, come and ask us on the Hackers Academy forum. It is one of the friendliest forums out there. All we ask for you to do is that when you ask your question, make it clear that you've done your homework. If you got stuck, do not give up in 2 seconds and jump on the forum and ask the question. Show us that you've done a bit of research, that you've done a little bit of homework. In your question, tell us that you've looked into this, you've looked into that, and that still doesn't help. So now you're on the Hackers Academy forum asking your question, and we'd be more than happy to answer it. If you still do not get an answer on the forum, which is very highly unlikely, drop your teacher an email. For this course, I'm your instructor, obviously. So drop me an email and I would be more than happy to answer. In other courses, you might have one or more than one teacher. Send them an email and I assure you they would be more than happy to get back to you. So here's what we're going to be learning in this course. First and foremost, we'll be talking about what the internet is and how does it work. It might sound trivial to you now, but believe me, there's more to it than what you think. Then we're going to be talking about internet protocols, what they are, how they work, and we move into services and ports. By the way, if all of this sounds Greek to you now and you don't understand what this is, don't worry. I do not expect you to know what this is. As a matter of fact, if you know what all this is, you probably shouldn't be taking this course and you can move on to the more advanced courses. Then we'll move into the 4 basic elements that you need to hack into any remote system. We'll dissect these elements, we'll talk about what they are and how you can get each and every one of them so you can execute a successful hack. Then we'll roll our sleeves and get down and dirty into packets. You are going to see how packets travel from your machine to the remote machine and dissect them and look into each and every packet. Now we're going to be talking about other common protocols that we see on the internet and how we can use them to our advantage. The following section is the one where we get our hands on our first hacking tool. We're going to be doing some port scanning, then moving to another hacking tool, doing a vulnerability scan, finding out the vulnerabilities that we're going to exploit, and last but not least, we're going to be taking advantage of these vulnerabilities, exploiting them, and gaining full remote access over our target system. So without any further delay, let's get started.
Hey guys, my name is Tariq and I'm your instructor for this course. It's 6:30 in the morning here and I decided to shoot this quick video just to say welcome to Hackers Academy and thank you for joining our courses. We're really thrilled to have you be part of our Hackers Academy family. And I wanted to share with you a quick tip on how Udemy rates courses in general. You'll notice that very soon you are going to get a pop-up message from Udemy asking you to give a rating for this course. And you might think, well, it's a little bit too early to be rating this course. We just went through the introduction and that was it. And I completely agree with you. Now, if you think the course is already worth 5 stars, then by all means, feel free to go ahead and give us 5 stars. But if you think it's way too early to be rating the course, then don't rate the course. It's very simple. Just skip the rating, wait until you finish the course, or jump ahead to whatever sections you're interested in and that matter to you. And then and only then, feel free to give us a rating that you think we're worth of. Now, if you think the course is worth the 5 stars, then by all means, please give us the 5 stars. The only thing that is keeping us on Udemy is your ratings and your feedback. We really don't make much money out of Udemy. You might have noticed that a lot of the courses are absolutely free or are relatively cheap. And if after that you still think the course is not worth the 5 stars, then give whatever rating you're comfortable with. But we only ask you to please give us some constructive feedback. Let us know what you liked, let us know what you did not like, so we can make our courses even better in the future. So that's it from me. Again, welcome to our Hackers Academy family, and I really hope you enjoy our courses. All the best.
It goes without saying that for you to be able to hack computers remotely over the internet, you need to have a good understanding of what the internet is and how does it work. A lot of people think that they know what the internet is, and if you go and ask anybody, somebody of your friends, your parents, your siblings, do you know what the internet is? Chances are they're gonna laugh back at you and they're gonna go, yeah, of course we know what the internet is. So, at the risk of sounding a little bit silly, I'm gonna ask you this. Do you know what the internet is? And how does it work? This is what this section is about. It's about understanding what the components of the internet are. So let's start by defining what the internet is. To put very simply, it's a global network of connected computers. So it quite literally is a whole bunch of computers all around the world that are connected to each other. Once we simplify this concept of what the internet is, anything attached to it, such as the concept of how hacking works, becomes simplified as well. This is how you start demystifying hacking. For a lot of people, hacking is sort of like this quote-unquote black art or mysterious magic. They don't know how it works and how does it happen. But once you understand that it's a big global network of computers, you start to understand that hacking is simply me accessing information on another computer elsewhere on the planet. You might be wondering, what do you mean by connected computers? Here's an article from The Guardian in 2013, and it says that damaged undersea internet cable causes widespread service disruption. Off the coast of Egypt, there was some damage in undersea internet cables, and this caused service disruption in some countries. So the internet is quite literally a whole bunch of cables, or at least part of it, is a whole bunch of big, massive undersea cables connecting continents and countries together. Here's another article, and it says that the US Navy was worried that Russia might be planning to cut the undersea cables that carry 95% of internet traffic. So internet is no longer this mystical big cloud that nobody knows where it is. Because a lot of people, when we're talking about the internet, they imagine that it's this cloud that's sitting somewhere and there's this whole bunch of data on it. But as a matter of fact, it's just this whole bunch of computers connected by cables, undersea cables, satellite, radio signals, so on and so forth. So when it comes to hacking remotely, when it comes to hacking a system over the internet or a computer over the internet, all what you're doing is you're trying to access information on that computer that is sitting remotely somewhere else. You're going through an undersea cable, you're going through a satellite, it really doesn't matter. If we want to think of it on a smaller scale, imagine that you are in your house and there are 3 or 4 different computers connected to your house router. This is a mini version of the internet. These computers that are in your house connected to the router here resembles the internet, and you can access information from one computer to another. This is what hacking basically is. It's as simple as that. Now, for hacking to happen, for you to be able to hack a system remotely, you need 4 main components. The first thing you need is an IP address. And don't worry if you don't know what this is, we're going to be explaining all of that. So the first thing you want is the IP address of the system you want to break into. 2, you want a running exposed service on that IP address or on that machine. 3, you want a vulnerability in the service that you can take advantage so that 4, you can exploit this vulnerability and gain remote control over the machine. So what's an IP address or an internet protocol address? We just said that the internet is a big global network of connected computers. These computers can be connected through cables, satellites, radio, etc. Now for these computers to talk to each other, they each require a unique address. If somebody wants to send you mail, they would need certain criteria such as your name, your street address, your city, your postcode, and so on. And the same goes for computers who are on any network. For any computer on a network to talk to another computer on a network, it would need an IP address. And this of course applies to the internet because the internet, like we said, is this huge, massive network. So put simply, an IP address is a unique address for every computer on a network that wants to talk to another computer. And they have a specific form. The form is number.number.number.number. And the number could be anything from 1 to 255. Let's take the example of these 2 computers on the network. On the left-hand side, you have a computer with the IP address of 192.168.1.1. And on the right-hand side, you have another computer with the address of 192.168.1.112. These are the IP addresses that are associated to these 2 different computers. And these are the IP addresses that these computers use when they want to communicate to each other. So if, for example, the computer on the left-hand side wants to talk to the computer on the right-hand side, it will be sending its traffic or its data to the address of 192.168.1.112, and the other way around. So how do I know what my IP address is? Let's do this exercise together. On your Windows machine, click on the Windows symbol on the bottom left corner and type CMD. This is shortcut for command prompt. The command prompt is a small piece of software that allows you to interact directly with the operating system. So instead of using the graphical Windows interface, you can type commands here that Windows will interpret and will give you the output directly. The command we're gonna do is ipconfig. This is the command that displays what IP address our machine has. And as you can see here, my IP right now is 192.168.237.132. Keep in mind that if you're following on this exercise, you might have a different IP address than mine. And if you do this exercise on another day, you might get another different IP address because these IP addresses could often change. Right, so now I know what my IP address is, but what if I'm targeting a system on the internet and I want to know what its IP address is? How do I know that? The easiest way to do this is to use the ping utility. Ping is a small piece of software that sends packets to a remote system and waits for a response. It's a diagnostic tool that is mostly used to check if another system is alive or not, or is responding or not. So what we're doing here is we're typing ping google.com, assuming that, for example, we're targeting Google. Obviously we're not, but just for the sake of this exercise. So we type ping google.com, and we see a reply coming from the IP address of Google. So now we know that in my country, Google's IP address is 94.201.252.25. So in theory, this means that if I now open my browser and I copy and paste the IP address in my browser, I should be able to access Google's page. Let's see if that works. Here we go. So as you can see, I can access now google.ae, which is the Google page for my current country of residence. Here's your first mission. Identify your own IP address. Like I did in the exercise using the ipconfig command, identify and note down what your IP address is. Then, identify the IP address of Google in your country. I am being redirected to google.ae, which might be different than the IP address of google.com or google.fr, and so on and so forth. And remember, record your success. Record down the steps you made, take screenshots, write down the answers, because at the end of the course, you're going to be submitting this to us to get a very valuable prize. So now you know what the Internet Protocol or the IP address is. To review very quickly, it's a unique address for every computer on a network. And because the Internet is this huge global network, every computer on the Internet will have its own IP address. Now there are a couple issues with this. If you look at this picture of a Google data center, you'd see a whole bunch of computers. All these closet-looking things that you can see in this picture, these are racks of computers stacked on top of other computers, stacked on top of other computers. There are hundreds, if not thousands, of computers in this picture. And this is one data center alone. Now imagine that each one of these computers here in the picture would need an IP address. What if Microsoft had these massive data centers as well, and each computer required an IP address? What if Apple? What about the rest of the world? Your university or your school or your home and so on? If every computer on the Internet required an IP address, we're gonna be very soon running out of IP addresses. And actually we are. There's a limited number of IP addresses that we can use. Roughly it's 4.3 billion. And right now we're actually running out of IP addresses. And the other question is, what if we don't want our IP to be public? Google has a public IP address that we discovered together because Google wants everybody to be able to access their website. What if I have my computer on my home network and I don't want it to be publicly available to everybody to access? This is when we use IP addresses that are not made public, i.e. private IP addresses. So a public IP address is any IP address that is directly accessible on the Internet. For example, hackersacademy.com would have a public IP address, such as Google, such as Yahoo, such as Microsoft.com, and so on. A private IP address, on the other hand, is not accessible from the Internet. So for example, right now, if you're connected to a school network or your home network, your computer would have an IP address that would not be accessible directly on the Internet. So if you're connected to a private network right now, your computer would have one IP address from the following pools. These are the pools reserved for private IP addresses. If you want your computer to have an IP address that is not accessible on the Internet, your computer would have an IP address that is picked from one of these three different pools. Anything from 192.168.00 to 192.168.255 to 255, which is a little bit over 65,000 IP addresses that you can choose from, or the second batch, which is a little bit over 1 million IP addresses that you can choose from, or the third batch, which is a little bit over 16 million IP addresses that you can choose from. So my IP address, for example, as you saw earlier, is from the first pool of 192.168.x.y. So if we want to take a very high-level bird's-eye view of how IP addresses are assigned, let's have a look at this diagram. The globe symbol in the middle resembles the Internet, and these 5 devices around it resemble public IP addresses that are connected directly to the Internet. So for example, one would be google.com, the other would be Microsoft, Yahoo, Apple, and hackersacademy.com. These are 5 different websites with 5 different public IP addresses that are particularly assigned to them and unique to them. On the outermost circle are the private IP addresses of everybody's home, office, and school network. So all these desktops and laptops and even mobile phones that are not directly connected to the internet would have a private IP address. Right now, other than your desktop or other than your laptop, if your mobile is connected to your wireless router at home, your mobile would have an IP address assigned to it. So here's what I'd like you to do. I'd like you to identify at least one other private IP address on your network. The easiest way to do this is if you find what your IP address is and try to increment or decrement by 1. So if, for example, my IP address is 192.168.1.10, I would try to ping 192.168.1.11 or .1.9. Another way to do this is to start from .0 and increment it 1 by 1 until I discover another IP address. So go ahead and try and do that and see how many IP addresses you can discover. And remember to record your success.
Now you know what an IP address is. What's the difference between a public IP address and a private IP address? To recap, a public IP address is an IP address that's accessible on the internet. It's publicly available, anybody can access it. A private IP address, on the other hand, is not accessible directly on the internet. So if you're connected to your home network, you're very likely to have private IP addresses on your laptop, on your desktop, and on your mobile. At this point in time, you might be right to wonder, how are you able to access the internet if you're using a private IP address? How is it possible that your machine with a private IP address is able to communicate with a machine on the internet with a public IP address? This is where NATing comes in place, and its sole purpose is to translate data from private IP addresses to public IP addresses and the other way around. This is an example setup we're going to be looking at, so we understand how NATing works. On the left hand side, we have two machines. Let's assume you're at home, you have two laptops connected to your wireless router. So the first one has the IP address of 192.168.1.111, and the second one is 192.168.1.112. These two laptops at home have private IP addresses. Both these machines are connected to your wireless router. If these two machines need to talk to each other, it's very straightforward and simple. All they have to do is redirect the traffic through the router and talk to each other. As a matter of fact, the router doesn't need to even be there. If you plug in these two machines directly through a network cable, they would still be able to talk to each other. So if you right now go grab a network cable, plug it into one laptop and then plug it in another laptop, you just created a network and these two laptops can talk to each other, provided that they have IP addresses within the same range, such as the ones in our example. The wireless router though makes it much easier for this to happen. So instead of plugging cables all across your living room, all you have to do is connect your devices, your laptop, your desktop, your mobile, to the wireless router, and it just redirects the traffic wherever it needs to go. So the router in this case will see traffic coming from 192.168.1.112, and it will see that it's destined to 192.168.1.111, and all it does is that it redirects it from the source to the destination. The device in the middle, this represents your wireless router. You can see that on one hand, on the left hand side, you can see that there's an IP address of an interface of 192.168.1.1. So if you grab your wireless router right now, you're gonna see that there are different ports, different places where you can plug in a network cable. If you plug in a network cable in one of these ports, you will get assigned one IP address. If you plug in the network cable in another port, you get assigned another IP address, so on and so forth. So your router would actually have an IP address of its own, meaning that if the device at 192.168.1.112 wants to talk to the neighboring device of 192.168.1.111, the data will have to flow through the router at 192.168.1.1. So the path that the data will take is computer A, router interface, then computer B. This is networking in its simplest form. Two devices on the same network talking to each other. We're gonna be showing you a video, an animated video in a moment, so you get a better understanding of this. Now the question is, what happens if one of these two machines want to talk to a server on the internet with a public IP address? You might have noticed by now that the router has two interfaces with two different IP addresses. So on the left hand side, it has the 192.168.1.1. On the right hand side, it has the 20.30.40.50. And this is a public IP address. So for example, if the machine on the left hand side at 192.168.1.112 wants to talk to a public IP address, in our case 8.8.8.8, the traffic will go first to the internal interface of the router with the IP address of 192.168.1.1, and then the router will have the job of translating this in such a way that it will be understood and routed to a public IP address. So internally what will happen is the router will take the data from 192.168.1.1 port and translate it to the other port at 20.30.40.50. And at that point in time, the data will be attached to a public IP address, making it possible for other devices on the internet to see it and communicate with it. And when the data is being sent back from the internet, it will reach the interface, the public interface at 20.30.40.50. The router will take this data, translate it to an internal IP address, and then forward it on to the destination. Perhaps a video will make it easier to visualize this. Let's have a look. So in our first scenario, our internal computers want to talk to each other. Both computers are at home with private IP addresses. 192.168.1.112 wants to talk to 192.168.1.111. And all it has to do is send the data to the router that will in turn forward it to the other machine. What if our internal machine now wants to talk to a public machine? The data will go through the router to the first interface at 192.168.1.1, then to the second interface, which has a public IP, all the way out to the internet, and then the other way around coming back in. Let's verify this. Let's have a look at what path our data is actually taking. To do this, let's go back to the command prompt and type ipconfig. This will show our IP address, and it will show us also the default gateway. The default gateway will be the IP address of the router's interface that does the NATing for us. There's another command that we can use in Windows called traceroute. And what this command does is, as the name suggests, it traces the route that our traffic takes to reach a destination. What we're doing now is we're doing a traceroute to hackersacademy.com to see the path that our packets are following. And as you can see, the very first hop that our data takes is the 192.168.237.2 IP address. In this case, this is the IP address of my router, which confirms what we have been talking about. For my machine on my internal network to be able to talk to hackersacademy.com, which is a public domain, the data will have to flow from my machine to the router that does the NATing and then gets sent to the internet. So here is your mission for this section. Go ahead and do a traceroute from your machine to Google and identify the IP address of your gateway. There's a very good chance that if you're on a wireless network at home, this is going to be the IP address of your wireless router. See if you can access this IP address and what you can discover on it. And remember to always record your success. Let's add one more piece to the puzzle of the internet. We already mentioned that IP addresses are a big part of the internet. This is the unique address for every machine that's publicly available on the internet that we want to talk to. However, obviously, it's really difficult to memorize IP addresses for every single website. Imagine that all the websites that you know by heart, instead of knowing the names of these websites, you have to memorize their IP addresses. And you'll have to type an IP address in your browser every time you wanted to open one of these websites. It's gonna be a major pain in the neck. A much easier way would be to memorize the names of these websites. Now the challenge here is that computers need IP addresses to communicate. So how would my computer know the IP address of Google when I type in google.com in my browser? This is the primary job of DNS. You can think of DNS as a database across the internet that keeps track of IP addresses and their corresponding names. So think of it, for example, as a big Excel sheet with two columns. In one column, you have the name of every single website, and in the other column, you have the corresponding IP address of every single website. These databases, these DNS databases, are spread all across the internet, and each one of them would have their own IP address. One of the most famous ones, for example, is the Google DNS database, which has the IP address of 8.8.8.8. So if you go right now and ping 8.8.8.8, you will get a response from it. If you trace route to it, you will get a response from it. So when I open my browser and I type google.com, what happens is that my machine will send a request to Google's DNS and ask it, where is google.com? The Google DNS will reply with the IP address. Then my machine will communicate with the IP address of the google.com web server. The web server will hand me back the google.com website. So how do I know what DNS server am I using? Go back to the command prompt and type ipconfig/all. And in one of the fields, you'll see the DNS server IP address. Right now, this is the IP address of the DNS server that my machine will talk to whenever it wants to find the IP address of a website that I'm trying to visit. So in essence, that means if I change my DNS to a different IP address, my machine will not be able to find the information it's trying to fetch. It will try to communicate to a different server which wouldn't have the DNS database in it, which means I wouldn't be able to access websites on the internet. Let's verify this and see how it works. On the bottom right corner on your Windows machine, open the Network and Internet settings. And click on Change Adapter Options. We're going to be accessing the network adapter settings and changing those. Right-click on the network device and click on Properties. Scroll down to find the Internet Protocol version 4 and click on Properties. Currently, I have a setting that requires my machine to automatically find an appropriate DNS server. If I change that to a different IP address, let's say 111.111.111.111, and I save this change, this is now going to redirect my machine to a different DNS server. In this case, 111.111.111.111. So now when I ask for the google.com website, my browser is going to send a request to the 111 IP address asking it, where is google.com? The 111.IP address does not have a DNS server on it. It doesn't have the DNS database. And as such, I'm not going to get a response that says this is where Google is. And as you can see, I failed to access the google.com website. Let's go back and fix this. Going back to the TCP IP options. And by the way, don't worry about what TCP IP is. We're going to be explaining this later on in the course. Let's go back and click on Properties. And now I'm going to put an alternate DNS server at 8.8.8.8. This is Google's DNS server. If I try to revisit Google again, you'll see that it works. Let's go find out why is this working now. Run the ipconfig/all command again, and you'll see in the DNS server settings, now I have two IP addresses for two different DNS servers. So what happened is, my machine tried to communicate with the first DNS at 111.111.111.111, and it didn't get a valid response. And as a result, it tried the other DNS, that of Google's, and that gave me the appropriate response. Make sure you go back and change the settings back to what they were. Here's your mission for this section. Identify what DNS you're using and answer the following questions. What's your DNS IP address? Is it a private DNS or is it a public one?
This is the final piece that completes the big picture of what the internet is and how does it work. What are servers exactly and what do they do? We mentioned DNS servers, we mentioned web servers. To put it very simply, a server is a dedicated computer that usually is more powerful and provides some kind of service. So for example, the DNS server that has the DNS database serves information from the database to whoever asks for it. We mentioned Google's DNS server, which has the public IP address of 8.8.8.8. So basically, it's just a powerful computing machine, like your laptop, only a lot more powerful, which has the DNS database, which contains all the IP addresses and their corresponding websites. Whenever somebody wants this information, like we did in our previous video, we ask the DNS server to serve us the IP address of the google.com website. And what that server did is it served us that information. This is why we call it a server. A web server is another example. So a web server would have a website and it would serve you pages whenever you ask for it. So if you go to hackersacademy.com, our web server will hand you out the page that you ask for. The training page, the About Us page, and so on. It will be serving you these pages. This is why they're called servers. I'm going to show you quickly how a server is set up. On my current machine, I'm going to set up a web server now. This is my IP address, 192.168.237.132. If I open my browser and I go to my IP address, I get an error saying web page is not available. There are currently no web pages available to be served on my own machine. So my machine does not currently have a server functionality running. Let's change this. Go to Control Panel, and I like to change the view to the smaller icons. Go to Programs and Features, and turn Windows Features on. This allows us to add more features to our Windows machine. I'm going to scroll down and find the Internet Information Services. This will help me publish a World Wide Web service. So it will help me publish on my machine web services, which basically is fancy talk for I'm going to publish a website on my own laptop. So I'm going to click that and turn it on and wait for the changes to apply. By doing that, I just switched on a web serving functionality on my own laptop. And as soon as the changes are finished, I'm going to go back to my browser and I'm going to refresh the page. And now as you can see, my laptop is serving a website. So practically what I've done is I turned my own laptop to a web server. It is now a machine that is serving websites to anybody who can access the IP address of my machine. Here's your mission for this section. I'd like you to retrace the steps you saw in this video and this time turn on the FTP server. If you don't know what an FTP server is, go and figure it out. And I'd like you to figure out how you connect to the FTP server. Once you've successfully completed that, make sure that you turn them back off again and set the computer back to its default state. We don't want any additional services to be running on our machine for a very good reason. We're gonna find out later why. Let's revisit one of the first slides that we started with on this course. We mentioned that for you to be able to hack remotely, you would need 4 different components. You will need the IP address of the machine you're targeting, exposed remote service running on that machine you're targeting, vulnerabilities in that service, and an exploit to be able to take advantage of that vulnerability. In the previous section, we covered what the internet is and why IP addresses are needed, what they are, what's the difference between a public IP and a private IP, how DNS helps us translate domain names or URLs to IP addresses, what servers are, for example, what a web server is or what a DNS server is, and how each server has an IP address assigned to it. We learned how to discover the IP address of the machine we're targeting. Together, we discovered the IP address of Google in your country and the IP address of hackersacademy.com. So now that we know what an IP address is and how do we discover the IP address, it is time to move on to the next stage. In this section, we're going to be covering services, what they are, how do we find them, and how do we find information about them. So what are services and what are ports? We talked earlier about web servers. We went through an exercise where we set up our own laptops to become web servers. We switched on, if you remember, some features on our Windows machine, the World Wide Web publishing service, and that transformed my laptop to a web server. So I had a website being hosted on my own laptop. When that happened, my laptop became a web server. So for the context of this course, consider the service is what runs on the server. So for example, when my laptop became a web server, because I was serving a website on it, on my laptop there was a web service running. It was switched on and it was running, waiting for somebody to connect to it. Here's an example that will make it a little bit easier to understand. Think of services as mobile applications. Right now on your mobile device, there's a number of applications, such as your camera application, your social applications, your calendar applications, and so on. Some of these applications will require access to the internet, whereas some of the other applications will not. So if you have an Android phone, for example, and you try to install a new application, it will come up with a list of permissions that the application requires from you. Sometimes, or more often than not actually, one of these permissions is access to the Wi-Fi or to the internet. Because a lot of these applications would want to connect back to the internet to retrieve data and updates and so on. There are other applications though that do not require access to the internet. So for example, it's very rare for you to be updating your camera application. Although it's an application running on your mobile that you use to take photos and videos, it's very rare that you would go online and update the camera application alone separately. So although these applications or quote-unquote services are running on your mobile, some of them would be connecting to the internet and some wouldn't. The same applies to any computing machine or any server. When I transformed my laptop into a web server, the web server service would allow it to connect to the internet or would allow people from the internet to connect to it. There are other services, however, that would not require connection to the internet but need to be running for certain operations on your machine. Let me show you a video so that you'd have a better understanding of what I'm talking about. And feel free to follow along with this video. The more you practice, the better you understand. On your Windows system, go to the bar on the bottom, right-click, and click on Task Manager. Click on More Details, and then navigate to the Services tab on the top right corner. This will show you every single service running on your machine. Don't worry if you don't understand what all these services are for. It's not necessary for now. Some of them are very easy to understand, such as the Windows Firewall, for example, or your antivirus that's running. So here's what we're gonna do. We're gonna try to start and stop some of these services and see what happens. Let's go to the control panel and reinstall the World Wide Web service. So again, I'm going to set up my laptop as a web server. I scroll down to the Internet Information Services and I reinstall it. We'll give it a second, and when it's done, I go to my browser and I refresh my home page. And you see that now I have a website running on my machine. So in that context, my laptop right now is a server with a web service running on it. Let's try and find the exact name of this service. I regroup the services to filter out the running ones, and here it is, World Wide Web Publishing Service. This is the service running behind the website. This is what makes it possible for me to access a website. Let's see what happens if I stop this service. Go down and click on Open Services, regroup the services by name, and scroll down to find the World Wide Web Publishing Service. We can see in the status here that it's running. I'm going to right click on it and stop it. So right now, I stopped the service behind the web server. I'm going to go back to my browser and I will try to refresh the page. And as you can see, I failed to load the page because the web service behind the web server is not running. I'll go back, right click and start it again and refresh the page, and here you go, it's running again. So now we know what a server is and what a service behind the server is. Obviously, like your mobile has so many different applications, a server can also run multiple services. We've seen how many services were running on my machine. So for example, a server could be serving you websites and emails at the same time. Now the question is, how would a server know how to direct incoming and outgoing communication? So for example, if a server is receiving web communication, somebody is asking it for a website, how would it know that this is website traffic and where would it direct to, as opposed to, say, for example, email traffic? This is where service ports come in place. Each service has an assigned port that accepts communication meant for that service. Think of a port as a doorway. And for that port to accept communication, it needs to be open. Again, such as a doorway. If it's blocked, it would not be able to accept any communication. So each service would have an assigned port for it, ready to accept communication as long as the port is open. These ports would have numbers, and a lot of these numbers are standardized around the world. So for example, If I'm going to be talking to a web service, there's a very good chance that I'm going to be talking to a port with a port number 80. If I'm going to be talking to a mail service or an email service, there's a very good chance that I'm going to be talking to a port number 25. So if you open your browser right now and type hackersacademy.com, you're going to be able to access the Hackers Academy website. Try, however, to type hackersacademy.com:8080, which is the stand port number for web. You'll see that you will get the same result. Why? Because your web browser will direct the traffic to port 80 anyway. So imagine here that you're talking to the Hackers Academy server. And at Hackers Academy, we provide two services for you. We have the website and we have the email. Whenever you're trying to retrieve information from our website, you are going to be communicating with port 80 on hackersacademy.com. Whenever you're sending or receiving emails, however, you are going to be communicating with port number 25 on hackersacademy.com. So here's your mission for this section. I'd like you to find out how many port numbers exist. What's the total number of ports out there? hackthisite.org has 3 services running on 3 different ports. Port number 22, port number 80, and port number 443. Don't worry for now again what TCP is. We're going to be explaining that later on. For now though, I'd like you to determine what these services are. What is the service running behind port number 22? What is the service running behind port 80? And what is the service running behind 443? We've already discussed what runs on port 80. So find out what the other 2 services are for.
I hope you've been enjoying the course so far. It's essential that you follow the steps that we recommended in the beginning of the course. If there's anything you're stuck at or you do not understand, please make sure that you review the video a couple times, go do some research on your own, ask on the Hackers Academy forum, and if all that doesn't work, drop us an email. Send me an email personally and I will make sure to respond. So far we covered what the internet is about, what are the components of the internet and how does it work. We talked about what IP addresses are, the difference between public IP addresses and private IP addresses. And we explained that these are unique numerical addresses for every computer or server on the internet. We explained what's the difference between a regular computer and a server, and the fact that a server would have a service running on it, such as a web service or an email service, and that we can communicate with this service to send and retrieve data. We also mentioned that these services would have port numbers assigned to them. In the following section, we're going to be discussing how do these services work, on what basis. So get ready, because things are beginning to get more technical now. In this section, we cover what I like to call interview questions. If you are going to begin your career into ethical hacking, as a junior penetration tester or as a junior ethical hacker, you are required to understand certain concepts, without which it's very difficult for you to land a job. Whoever is conducting your interview wants to know that you have a very good understanding of certain concepts. And these are the concepts that are going to follow in this section to the end of the course. We're going to be covering what packets and protocols are, what port scanning, what vulnerability scanning, what exploitation is, and so on. Now keep in mind, like we said earlier, that there is no way we can cover everything in one course, or in multiple courses for that matter. There is a lot that one can learn. However, what I'm trying to give you here is the stepping stone into the world of ethical hacking. So once you know what a packet is and how does it look like, and what a protocol is and how does it look like, instead of me trying to teach you about every single protocol that's out there, which is an impossible task to do, what I would invite you to do is that you would go and study about all the common protocols. In this section, we're going to be talking about a few main ones that you definitely, absolutely should know about, that you cannot start without knowing about. Remember, this is the hacking course for beginners. So we're going to be helping you to begin in the following sections. And then later on, you want to go and expand your knowledge on your own. Let us begin by talking about packets. Between computers, data isn't sent whole. Whether you are communicating with another computer, another server, another mobile, whatever data is being sent between them wouldn't be sent as whole. When we say data, we mean pretty much anything that's being communicated. Pictures, videos, documents, emails, etc. The sending computer would break the data down into what we call packets, and the receiving computer on the other end would reassemble these packets and see and read the data. For example, if the computer on the left-hand side wants to send a message to the other computer saying, "Hi, how are you?" it will break it down into different sections or different packets. Hi, how are you? And it will send them in that order. The receiving computer on the other end will reassemble these packets and then read the message as a whole, understanding that it's a question asking, "Hi, how are you?" in order for it to respond. How is this broken down and how is it reassembled on the other side? This is what protocols is about. Because there are some questions that we need to be asking ourselves right now. The first obvious question is, how do we make sure that the data is being sent to the correct recipient? Do I just blast the data out on the internet and hope that the recipient will get it? How do I know that it's being sent to the correct port? We mentioned earlier that some servers would be providing more than one service, for example, email and web. How would I know that the receiving server is getting the email on the email port and not on a wrong port? How would I know that my data's integrity is intact? How would I know that, for example, my email is being sent in the correct manner and we're not losing some words or some pictures or some quality of the pictures in our email attachments? How would I know that the recipient is able to restructure the data in a correct sequence? To answer these questions and more, we rely on protocols. In the world of networking, protocols are a set of rules dictating how to communicate. For example, when you're communicating over the phone, it's the protocol that you pick up the phone, say hello first, and then initiate the conversation. You wouldn't say hello before you pick up the phone. You definitely wouldn't initiate the conversation without answering the phone. It just wouldn't work. Similarly, in the world of networking, this is what protocols dictate and mandate. Now, for the internet to work, we would need a number of protocols stacked on top of each other. What do I mean by that? Going with answering the phone example. In some countries, for example, it's customary and it's the protocol to start with a courteous conversation, asking about the other person, how they are, how their family is, how they've been, and so on. You wouldn't just pick up the phone and say, "Hey, how's it going? I want this." That would be incredibly rude in some countries. In other countries, maybe that works. So there are different protocols depending on where you are and who you're communicating with. The sequence, for example, would be: first, you hear the phone ring. 2, you pick up the phone. 3, you would answer the phone, saying hi. 4, the other person would respond by asking a number of questions. How are you? How you been? How's the family? And so on. And then 5, the communication channel is open to exchange any kind of communication. The Internet Protocol, or the IP, which is the protocol that we mentioned very earlier on in the course, is one protocol that has a simple job of labeling communication with a source and a destination address. We've seen what IP addresses look like. These numbers have the only purpose of taking care of the recipient and the sender. So the Internet Protocol has the job of just delivering stuff. It doesn't worry about the order of delivery. It doesn't worry about whether it's being delivered in the correct order. All it does is that it knows who the address is and who the recipient is, and it just delivers. So if we look at an IP packet, this is what it would look like. This is an oversimplified IP packet, obviously. We're going to be looking at actual packets in a moment. But for now, an IP packet would look something like this. It has a source address of the sender, it has the destination address of the recipient, and some other kind of data that we really don't care about at this point in time. Another protocol that is very common on the internet and in networking is the Transmission Control Protocol, or TCP in short. And this is the protocol that handles the correctness of the order of the packets being sent, whether a packet has an error in it, or whether a packet has been lost or not. So for example, if I'm sending the "Hi, how are you?" message from one computer to another, the Internet Protocol would look after who the sender is and who the recipient is, and would make sure that the message has been delivered to the correct recipient. The TCP protocol would make sure that the message is being sent in the correct order. So the "hi" is being delivered before the "how" and not the other way around. And will also make sure that the packets are correct, the content of the packets is correct. So for example, the "how" is being delivered as a "how", not as a "who". And then lastly, it will check for lost packets. So if a packet has been lost on the way, has been dropped for whatever reason, it will ensure that the packet is being resent. For this to happen, the communication needs to be initiated in what we know as the TCP handshake. The initiation of the phone call, when you hear the phone ring, you pick it up and you say hello. This is very similar to what a TCP handshake is. The TCP handshake works as such. The sender, whoever wants to initiate communication, will send one packet called the SYN packet. This is the synchronization packet, which is basically a packet that says, "Hi, I would like to talk to you." The recipient, on the other end, will respond with a SYN ACK packet, which is an acknowledgement of the synchronization message. It's similar to a response saying, "Yes, I hear you. Let's talk." And then the initiating end will send one more packet, which is the acknowledgement packet saying, "I acknowledge that you can hear me. Now we can start the communication." So when it comes to phone conversations, it's similar to you hearing the phone ring. This is the SYN packet. Somebody is asking to talk to you. You pick up the phone and you say, "Hi." This is you acknowledging that you heard the phone ring and you answered it. You're ready to talk. And then the other end would respond by saying, "Hey." This is them acknowledging that they can hear you too on the phone, and then the communication can begin. And here's what a TCP packet would look like. It's a little bit more complicated than the IP packet. All the IP packet had was a source address and a destination address. The TCP packet, on the other hand, has more information. It has the source port and the destination port. So if I'm talking to a web server, we mentioned earlier that it's very likely I'm going to be talking to port 80, which is the standard port for web. So I would know that in my TCP packet, the destination port would be 80. The source port, however, would be something special to me, which is the port where my data is leaving from. It doesn't have to be port 80, it could be any port. The third field that you see here is the flags. What we mentioned earlier in the TCP handshake, the SYN, SYN ACK, and ACK, these are called flags. And you can see these on the TCP packets. And then there's a whole bunch of other stuff that we don't care much about at this point in time. So remember when we mentioned that for the internet to work, we would need multiple protocols stacked on top of each other? This is what a TCP IP packet would look like. If you are in the world of networking or IT, you would have heard the term TCP IP so many times. And if you get into the world of ethical hacking, or IT for that matter, you cannot go one day without talking or hearing about TCP IP. TCP IP is short for TCP over IP, and it basically is a packet of TCP stacked on the packet of IP. So in this example, we have a packet of IP taking care of the source address and the destination address. I'm communicating to a web server, so I know that I am the source address and the destination address would be, in that case, let's say hackersacademy.com. The IP packet's job is done. On top of it, I would know that I'm communicating from X port to port 80 on the Hackers Academy server. And if I'm initiating the conversation, the flag on the TCP packet would be the SYN packet. So what is the web traffic exactly? There is the IP packet taking care of the source address, the destination address. There's the TCP packet taking care of the data sequence, the error correction, and the drop packets. But what is the web data? The web data is in a third protocol called the Hypertext Transfer Protocol, the HTTP. HTTP is the basis of data communication on the internet, on the World Wide Web. This is how we transfer graphics, video, audio, text, and links. And it works similar to TCP. So for example, if I'm trying to retrieve the logo from hackersacademy.com, I would send what we know as the GET request, an HTTP GET request. I will ask the server to give me the logo. The message that I would send would tell the server that I want to get the logo. The server would respond with an acknowledgement message saying, "I acknowledge your request," and then the server will send another message saying, "Here's the logo." So now an HTTP request would look something like this. You have the IP with the source address and destination address, my source address and the destination address of hackersacademy.com. You have the TCP taking care of the correctness and the sequence of the data and so on, with the source port from my machine to the destination port of 80 on the Hackers Academy. You would also have the flags of the TCP packet depending on which part of the communication we're on. And then you would have the HTTP stuff that we just mentioned. For example, the logo from hackersacademy.com website. Alright, so enough theory. Let's have a look at what packets actually look like. Download the packet capture file and open it using Wireshark. I've pre-captured some packets for you that I'm going to walk you through. So now you can see what a TCP packet looks like, what an IP packet looks like, and how the HTTP communication looks like. If you have correctly installed Wireshark, all you have to do is, after you download the packet capture file, double-click on it and it will open automatically in Wireshark. There are a total of 7 packets in this capture, and we're going to walk through them one by one. First, let's talk about the interface of Wireshark. On the left-hand side, you have the sequence of the packets. So you can see that this is the first packet where the communication capture started, and this is the last one, number 7, where I stopped the capture. This is the time where the packets were captured. You have the source IP address and the destination IP address. You have the protocol of the packet captured, the length of the packet, and some more information. So let's click on the first packet and expand it. Skipping to the third field, you can see that this is an Internet Protocol version 4 packet. So this is an IP packet with the source IP address of 10.10.192.92. This is my machine's IP address. And the destination is 94.201.252.25. This is the IP address of Google. This is the Transmission Control Protocol field, or the TCP field. The TCP communication is leaving my machine from the source port of 63379 to the destination port of 80. So now I can tell that I'm trying to talk to this IP address, the Google's IP address, on port 80, which means that I'm talking to a web service. If you go down a little bit, you will see that there's a SYN flag being set. This is the first packet of the TCP three-way handshake. So here I'm initiating the conversation with the Google server. Let's have a look at the second packet. Now the source has changed. So now the communication source is Google's IP address, and I am the destination in this case. The packet I'm receiving is a TCP packet with the SYN ACK flag set on. Let's have a closer look. This is the IP information, the source and the destination, which we already know by now. And this is the TCP information. So now the source port is 80 and the destination port is 63379. The information between the first packet and the second packet has now been inverted. In the first packet, number 1, the source was me, the destination was Google. The source port was my source port, and the destination was also Google's at port 80. Because I was initiating the conversation, it was me who started the conversation. And then Google responded. So now the source is Google and the destination is myself. And the response came from port 80, which I started communicating with, to the destination port on my machine. You can see now that in the second packet, the TCP flags SYN ACK are set. So Google has acknowledged my SYN packet and is ready to start communication. The third packet I send is the last in the TCP handshake, which we expect to have the ACK flag on. So now again, I'm communicating with Google, sending a TCP packet to port 80 with the ACK flag being set as on. So now, my TCP handshake is done and the conversation is ready to begin. I have my TCP stacked on top of IP. Now it's time to use the HTTP. The first thing I'm asking Google to do is give me an image, the Google logo. And I do this by using the HTTP protocol GET request. Remember what we talked about? In HTTP, we have GET requests that we can use to retrieve information from the web. And here what I'm asking for this logo, which lives on Google's server under the images directory, branding, and so on. So let's have a closer look. The first thing you'll notice here that there's another additional field. The previous packets, if we look back at it, had the IP and the TCP. Now, we have the IP, on top of it, TCP is stacked, and on top of it is the HTTP. Let's open this and have a closer look. This is the HTTP GET request. So the server will know that I'm asking for the following URL. images/branding/Google logo, and so on. I'm retrieving or I'm asking for this logo. So how would Google respond for my request? We see that in the next packet. Notice that there is no longer an HTTP field here. All what's happening is that Google now is responding with an ACK. It's saying, I acknowledge your request and I'm going to send you the logo. And then it follows it with an HTTP packet of its own. So now the HTTP communication has been initiated as well, and it's happening, to which my machine will respond with a TCP ACK packet. Let's summarize. I want to retrieve an image file, a logo file from google.com. The first thing I do is I initiate the conversation. I give Google's phone a call, and this happens through the TCP SYN packet. Google hears the phone ringing and acknowledges my call and responds by a SYN ACK. Google picks up the phone and responds by saying hi. I respond by saying hello. So I acknowledge Google's acknowledgement, and in the third packet, I respond to Google's response. The first three packets are the TCP three-way handshake: SYN, SYN ACK, ACK. After the initiation of the conversation, it's time for me now to ask for what I want, and I send the HTTP GET request using the Hypertext Transfer Protocol. Google acknowledges my request and continues talking HTTP to me. And then I acknowledge Google's HTTP communication. Here's your mission for this section. We saw the flags on the TCP three-way handshake: the SYN flag, SYN ACK flag, and the ACK flag. Find out what other flags TCP uses and what are they used for. Then, using Wireshark, capture traffic from hackersacademy.com. Try to identify the source and destination IP addresses. And try to identify the source and the destination port you're communicating from and to.
In this section, we're going to set up a lab on our machine. This is a virtual environment lab, so you can install any operating system you want in the virtual machine. You can keep it for as long as you want, practice on it as long as you want, and do to it whatever you want. It's very easy to reset, and it's 100% legal. To do this, we're going to install a piece of software called VMware Player. Go to the VMware website, and under Products, find the Workstation Player. Click on Try it for free, and download. Once the download is complete, double-click on the setup file, and follow the instructions. If you're prompted for a license key, just click on Use for Free, enter an email, any email, and click on Finish. And now the setup is ready. The second step in setting up our lab is installing the target environment. Go to the URL provided and download the Metasploitable operating system. This is a Linux operating system that has been set up and configured in such a way that it is vulnerable and exploitable. Once you've downloaded it, extract the file, and then double-click on the VM file. When you do that, it will automatically open in the VMware Workstation Player. It boots up, And now it's ready for you to log in. The username and the password are the same, msfadmin. To find out what the IP address of your target machine is, type ifconfig. And make sure that there is a connectivity between your Windows operating system and your target machine. You do this by opening the command prompt on your Windows system. And type ping and put the IP address of your Metasploitable Linux. You should be able to see a reply from the IP address you're pinging. And now you have a lab setup. Note down the IP address of the Metasploitable machine. This is going to be your target IP address going forward. It's time to get our hands on some hacking tools. Before we begin though, our lawyers have advised that we share this disclaimer with you, so please take a moment and make sure that you read it. Now that you read the disclaimer, let's begin. Let's revisit one of the earlier slides. We said that to be able to hack remotely, you would need to have 4 different things. 1. The IP address of your target. 2. An exposed remote service running on the IP address. 3. Vulnerabilities in services. And 4. An exploit. We've talked in length about IP addresses, the Internet Protocol, and other protocols. And the reason we went into such details is because now it's the time that we explain how you can discover remote services running on your target. And we do this using a technique called port scanning. So what is port scanning? Remember when we said that different services have different ports? So for example, the web service would have port 80 open, the mail service would have port 25 open, and so on. So an open port is an indication that there is a service running behind it. Port scanning is a technique of identifying open ports and identifying the service running behind that port. And it happens by connecting to each port and analyzing the response that we get from this connection. Meet Nmap, or Network Mapper, your first hacking tool. Nmap started as a port scanner, and then it developed into much more than just that. Now it does things like operating system identification, service identification, and a whole bunch of other things that we cover in more advanced courses. By default, when we're doing an Nmap scan, Nmap does a SYN scan. We'll talk about what that is in a second. The response to the SYN scan will determine the state of the port. If you get a SYN ACK response, that means the port is open. If you get a reset response, that means the port is closed. And if you get no response, that means the port is filtered. What does all that mean? Remember when we talked about the TCP handshake? We weren't talking about this just for the heck of it. There's a reason why we were explaining all that. A SYN scan happens as such. The port scanner, your Nmap tool or any port scanner, if you're doing a SYN scan, will start by sending a SYN packet to the target. So let's say, for example, you try to identify whether port 80 is open. What Nmap does is that it sends a SYN packet, so it starts the TCP 3-way handshake. What do we expect in response to the SYN packet? If you remember, the normal response is a SYN ACK packet. And this is where the port scan stops. Let's compare that to the 3-way handshake. The 3-way handshake sends the SYN packet, expects a SYN ACK packet, and then responds by an ACK packet. So when we did the packet analysis in a previous exercise, when we were initiating the conversation with Google, we saw through Wireshark that the first packet that we sent was a SYN packet. Google responded with a SYN ACK packet, and then we responded back with an ACK packet. That was our 3-way handshake, trying to communicate with port 80. A SYN scan, however, wouldn't complete the 3-way handshake. All it does is that it sends a SYN packet to the port you're trying to scan, and it waits for the response. If the response is a SYN ACK, that is an indication that the port is open and is ready to communicate. And this is where it terminates the scan. It stops, because now it has all the information that it needs. If the answer, on the other hand, is a reset packet, that means the port is closed, and we cannot communicate to the port. If we get no response, that means chances are that the port is filtered. What do we mean by filtered? That means there's some kind of a network security device, such as a firewall for example, controlling access to this port. It might have detected that you're doing a port scan and it dropped your packet. It wouldn't allow you to communicate with this port. And as such, we assume that the port is filtered. Installing Nmap is pretty straightforward. You go to the Nmap download page, download the executable file, and just follow the instructions. Using Nmap is pretty straightforward. All you have to do to perform a default scan is write nmap space the target. For this exercise, we're going to be scanning hackthisite.org. This is a hacking practice website that gives permission to everybody to try and hack it. And as you can see, Nmap has started. To see what the progress is, you can hit the enter or the return key. Every time you hit the enter key, you'll get an update of how long the scan has been going on and how long is remaining. At the moment, we have about 10 seconds remaining. And here we go, the scan has finished. If you look at the results, it shows that there are 3 ports open: SSH at port 22, HTTP port 80, and HTTPS port 443. Here's your mission for this section. I'd like you to explore the other options for Nmap scans. We mentioned that the default type of scanning is a SYN scan. There are other types of scanning. Try and find out what these are and how do they work. Following that, I'd like you to perform an Nmap scan against the target machine in our lab. See how many ports you identify as open, and try to figure out what are these services running behind these ports. Do a little bit of research and see if you can determine what these services are and what are they used for. By now, you're able to identify the IP address of your target machine. And using port scanning, you can also tell what ports are open and what services are running behind these ports. The next step in the hacking process is to identify vulnerabilities in these services. And we do this using a technique called vulnerability scanning. In the world of information security and ethical hacking, a vulnerability is equivalent to a weakness. The simplest example of a vulnerability is an easy-to-guess password. So for example, if you set up your email with an easy-to-guess password such as your name, the name of your dog, or the name of your mom, this is considered to be a vulnerability. Anybody who knows your name, the name of your mom, or the name of your dog might be able to guess your password. And that means that you've chosen a weak password, making your email vulnerable. Vulnerability scanning is the process of identifying these weaknesses automatically or using automated tools. So let's say, for example, you have a wireless router at home, and your password protected the access to the wireless router. A vulnerability scanner might be able to identify this weak password by trying multiple passwords in a very short period of time. So instead of you trying these passwords one by one manually, a vulnerability scanner would do this for you automatically and much faster. And this is what vulnerability scanning is about. It's trying to identify weaknesses using automated methods and automated tools. One of the best vulnerability scanning tools out there is called Nessus. It's free for home use. You can download it from the Tenable.com website and use it to scan our virtual environment target machine. To download Nessus, go to the products page and find the Nessus Home tab. Fill in the registration form and you'll be redirected to the download page. Click on download, choose the operating system. In this case, I'm going to download it on my Windows machine. Click on agree. And when the download finishes, click on the setup file and follow the instructions. When the setup finishes, your browser is going to open and redirect you to the Nessus setup page. Take note of that page. It's at https://localhost:8834. This is how you're going to be accessing Nessus page from now on. To skip the exception on Chrome, click on Advanced and proceed to Location. Click on Continue and set up a username and a password. This is the username and password you're going to be using to log into the Nessus interface going forward. Get the activation code from your email. You should have received an email by now after you completed the registration form. Put in the activation code and click on Continue. Nessus is going to take some time to finish downloading some extra stuff and some plugins. Might take a while, so be patient. Once that's complete, log in using the username and the password you set up previously. And with this, your Nessus installation and setup is now complete. Now let's use Nessus to scan our metasploitable target machine. Before we do that, let's verify the IP address of our target machine. In this case, the IP address of my target is 192.168.140.128. Take note of this IP address. If you're not logged into the Nessus interface yet, make sure you do that by going to the https://localhost:8834. Type in your username and password and sign into Nessus. Once you're logged in, you want to create a new scan. So click on the New Scan button. You're going to see a number of templates in front of you. We're not going to be discussing all of that. We'll do this in more advanced courses. For now, we'll just stick to the basic network scanning option. So click on Basic Network Scan and give the scan a name that will make sense to you. Mine, I just call it my first scan. And in the description box, you can insert more details if you want. I just typed the IP address plus full port scan. I'm going to explain why in a second. In the target box, I'm going to fill in the IP address of my Metasploitable machine. Once done, click on the Discovery section. In the scan type, if you click on the drop-down menu, you'll see 3 different options: Port Scan Common Ports, Port Scan All Ports, or Custom. Remember in the protocol section when we talked about the TCP, I asked you in your mission to find out how many TCP ports are out there. If you choose the Port Scan Common Ports option, your port scan is going to be limited to a number of common ports. However, if you choose the Port Scan All Ports, it will try and scan for every single TCP port, which is much more comprehensive. However, it takes a longer time. But because we're scanning only one target, we're going to be going with the more comprehensive option, and we're going to choose All Ports. And this changes the settings. It reflects in the settings below, telling us that now we're going to be scanning all ports from 1 to 65535. Now our scan is set up and complete. We click on the play button and the scan is running. At any point in time, you can click on the scan, see the progress, and check the results. The results will continue to populate as the scan runs. It's going to take a while, so we're going to leave it for now and come back later. You'll see that the number of vulnerabilities have jumped from 6 to 15. If we click on the vulnerabilities, we can go through them one by one. And now the number of vulnerabilities have increased even more. We can see there's a number of critical vulnerabilities, a number of high, and a number of medium vulnerabilities. As the scan goes, we can click on every one of these vulnerabilities and find out more information about it. So as you can see, Nessus have identified in excess of 100 vulnerabilities, 103 vulnerabilities to be exact. Each one of these is a potential weakness that we can exploit to gain access over our target machine. As an ethical hacker, your job is to go through this report and test for these vulnerabilities one by one. Just because a vulnerability is there in the report doesn't mean that we can exploit it. It could be a weakness, but that does not mean that we have the tools or the programs that allow us to take advantage of this weakness. So you can click on any vulnerability if you want to read the description and find out more information about it. How we take advantage of these vulnerabilities is what we're going to be learning in the next section. Your mission for this section is to replicate what I've done. Install and set up Nessus, log into it, and perform a scan against your Metasploitable machine. And now we reach the most exciting bit of hacking. We've identified the IP address of our target machine. We identified what services are running on the machine, and we were able to see if there are any vulnerabilities affecting these services. The next and last step in this course is to take advantage of these weaknesses and exploit them in such a way that we can gain remote control over the target machine. And we do this using exploitation. So what is an exploit? An exploit is taking advantage of the weakness. We want to take advantage of the vulnerability that we identified. Just because we found out the vulnerability doesn't mean that we now have control over the system. If the vulnerability is there, but we cannot take advantage of it, it's of no use to us. So an exploit could be as simple as guessing the correct password, for example. If your target machine has a weak password and you're able to guess it and connect to it remotely, you have successfully exploited the machine. The vulnerability in that case was a weak password, you took advantage of it, you exploited it, and you got full control over the machine. This is what an exploit is in its simplest form. A more complex exploit could be writing a particular program specifically tailored to the target. And this comes at later, more advanced stages in your hacking career. Luckily for us, there's an amazing tool that packages thousands and thousands of exploits in one package. And the tool is named Metasploit. You can either download and install Metasploit from their website, or you can use it from one of the readily available Linux distributions that are specially configured for ethical hacking. I'm going to include a separate video on how to download and install one of the Linux distributions that come pre-packaged with Metasploit, Nmap, and a whole bunch of other tools. It is a Linux operating system though, so if you're still not comfortable with Linux, you can download and install Metasploitable for your Windows operating system. To do this, go to the Metasploit.com website and click on Free Metasploit Download. You're going to have to submit a request asking for a copy of Metasploit. That might take a few days for them to review the request and provide you with a copy. Once you have the Metasploit setup file, it's a straightforward process. Start the setup, follow the instructions, and you'll be done in no time. Keep in mind though that Metasploit has a lot of different exploits pre-built into it, and some of these exploits do not agree with firewalls and antiviruses. So if you have an antivirus setup, it might complain and pop up alerts saying that there are viruses being installed. That's not the case. These are just exploits that your antivirus might confuse for viruses. So now that you have Metasploit installed and you have all these exploits ready, let us explore how you can use this to take advantage of some of the vulnerabilities we identified in such a way that you can gain full control over the target operating system. Let's go back to our Nessus scan and open the report. In the report, you'll find a vulnerability titled VNC server password. What this basically says is that there's a service running on our target machine called VNC, and it has the weak password of password setup, which means that we would be able to connect to this remote server using the password. For you to be able to do that, find the Metasploit installation on your Windows machine, and under the Metasploit, you'll find a VNC viewer button. This is a VNC software that allows you to connect to a VNC server. If you're able to connect successfully to VNC server, you will have remote access to the target machine. For you to do that, fill in the IP address of the target machine, and the password we know by now that it is password. This is what Nessus was able to identify as a weakness. So we're just going to type password. And here we go. We now have graphical remote access to the Metasploitable machine. If you type who am I, this is a Linux command that returns the identity of the logged in user. You'll see that the output is root. On Linux, root is the equivalent of the super administrator on Windows. So now you have graphical access to the remote machine with full administrative control, just because one of the services on it has a weak password. Let us try a more complex exploit, something a little bit more fancy, something that looks a little bit more like hacker type stuff. Let's go back to our Nessus report and scroll down to the medium section vulnerabilities and find a vulnerability that starts with Samba 3.0.0. If we read the description of the vulnerability, it tells us that we can, using that vulnerability, exploit remote code on the machine, which means that we might be able to exploit the machine remotely. To read more about it, we can also see a link provided by Nessus. The link has a CVE number, which is a number unique to each vulnerability identified. Remember, just because there is a vulnerability, that does not mean that there is an exploit to this vulnerability. So there is a weakness, we know this for now. But can we take advantage of this weakness? Is there a way we can exploit it to our advantage so that we can take full control over the remote machine? Let's find out. There's a website dedicated to recording every single vulnerability out there. And you can find this website at exploit-db.com. Let's see if there's an exploit to the vulnerability. Click on search. And type in the CVE number that was identified by Nessus. Type the CAPTCHA and click on search. It seems that we are in luck. It looks like there's an exploit to the vulnerability. This is what an exploit looks like. For this particular vulnerability that affects the Samba service, the exploit is the code that you're currently looking at on this page. In the days before Metasploit, to be able to exploit a vulnerability, you would have to either find the pieces of code online or write this code yourself. If somebody has already written the code for you, there would have been a very good chance that the code wouldn't work on your target. You would have to take the code and alter it, change IP addresses, change other parts of the code for it to work. So you are forced to have a very good understanding of how exploit code works and how you can edit it in such a way that you can make it work to your particular target. Luckily for you now, as a beginner, you do not have to do that anymore. So you can see here that the author of this particular piece of code is Metasploit, which basically means that if we go back to our Metasploit software, the exploit code is there and we can edit it directly from the Metasploit interface. So we're going to search for that particular vulnerability. We type in search and the CVE number. So here we go, we found the exploit. To tell Metasploit that I want to use this exploit, we type in use and the path to the exploit. An easy way to do this is if you type the first few letters and hit the tab key, and Metasploit will complete the string for you. So type use, expl, tab, multi-tab, and so on. Notice now that the prompt of Metasploit has changed from MSF to MSF exploit user map underscore script, which basically means now we're setting up the exploit that we're going to be used to take advantage of the vulnerability. The next step we want to do is we want to configure this exploit to target our particular Metasploitable machine. To find out what kind of settings we have, we type show options. And we can see that we have two options we can change. The R host, which is the remote host, and the R port, which is the remote port. Obviously, I want to set the R host to match the IP address of my target machine. The way I do this on Metasploit is I type set space R host and the IP address of the target. I click on show options again, and now I can see that the IP address is set in the field next to the R host. To run the exploit so that I can take advantage of the vulnerability, I type run and hit enter. But unfortunately, nothing happened. The reason nothing happened apparently is because I forgot to turn off my firewall. Remember when we mentioned that Metasploit doesn't like firewalls, or firewalls don't like Metasploit? So I want to go on my Windows operating system and turn off the firewall. Once that's done, I'm gonna try and run the exploit again. And now it looks like it's working. The exploit has finished running, and it looks like I have some kind of command prompt which I can use to type commands directly onto the target machine. So the first thing I want to do is find out what kind of access do I have on my target machine. I type who am I, and the response is root. So now I know that I have root or super admin access to the target machine. I type ifconfig to see the IP address and just verify that I am actually on the target. The IP address I can see is 192.168.140.128. Let's switch back to the VMware and see if it's the same IP address. There you go, 192.168.140.128. Let's do a little bit more of verification. I'm going to create a text file on the target machine using my Metasploit console. The command on Linux to create a file is touch and file name. So I'm just going to create a text file titled hacked. I type touch hacked.txt. Let me verify this. I'm going to do this just for the fun of it using VNC. To list the files on the current directory that I am in Linux, you type ls. The ls command will list all the files that are available in the directory. And as you can see, there's a hacked.txt file created on the remote machine. As an ethical hacker, always make sure that you remove anything that you created. And you do this using the rm command, rm hack.txt. Let me double check that it's removed. I type ls again, and the file is not there. So I verified that I have full control over the machine. As root access, I can create files, I can remove files, and so on. To terminate the session and exit the exploit, I click Ctrl+C. So there you go. You have successfully exploited a remote machine using Metasploit. You have gained full control over it with root level access. You were able to create files, delete files on it, and you could have done whatever you wanted to that machine. There's a reason why I particularly chose this vulnerability that I chose. If you've noticed, it was within the medium category. It wasn't a critical vulnerability, it wasn't a high vulnerability, it was a medium. And by doing this, I wanted to convey a certain message. That you as an ethical hacker should never ignore any vulnerability you find in the vulnerability report. You should make an extra effort to verify each and every single one of these vulnerabilities, even the medium and low ones. A medium vulnerability in this case provided us with full root access over the target machine. So had we ignored it just because it was a medium vulnerability, we would have made a critical mistake. So your mission now is to go back to the Nessus report and review all these vulnerabilities, pick one of them that works with Metasploit, and try and exploit the machine using a different one than the one we showed you in the video. Good luck!
With this, we reach the end of our Hacking for Beginners course. I would like to congratulate you on completing this course. You've come a very long way since we first began. We covered a lot of ground in this course, although it was a short course, but make no mistake, we have covered a lot of ground, and I hope by now you have gained a solid foundation and a very good understanding of all these concepts that we discussed in such a way that you can now start building on top of these. We talked about what the internet is and how does it work. What are IP addresses? What is the difference between public IP addresses, private IP addresses, and why they are needed? We talked about network address translation and how it connects private IP addresses to the internet. We also explained what DNS is and how it's an integral part of the internet. We talked about what servers are, what services are that run on these servers, and how all this comes together to create the internet that we know of. And we said that for you to be able to hack remotely, you need 4 different components: the IP address, an exposed remote service running on the IP address, a vulnerability in the service, and an exploit. Then we proceeded to explain what services and ports are, and how each service would have a different port number. For example, mail would have port 25, and web would have port 80. But that's not just it. We said that the web does not have a port number only assigned to it. It also has a protocol assigned to the port number. So for example, web would be running on port 80 on TCP, the Transmission Control Protocol. We explained what protocols are, how the Internet Protocol or the IP has the sole purpose of delivery. It cares about the source and the destination only. How the TCP, which works on top of IP, takes care of the correctness of the order of packets, the errors in the packets, and the lost packets. And we explained what the TCP three-way handshake is. We also talked about HTTP, the basis of data communication on the World Wide Web, and how HTTP works in conjunction with TCP and IP. We looked at an HTTP request and we dissected some packets. We looked at the IP packets, we saw the source IP address, the destination IP address, the source port number, the destination port number. We looked at the TCP packets and we saw how the flags are set, the SYN flag, the SYN ACK flag, and the ACK flag. And we saw how the HTTP GET request works. Then we moved on to talk about how you can identify open ports and running services on machines, and how you can do that using port scanning. And then you got introduced to your first hacking tool, Nmap. You learned what a SYN scan is and how does it work, and you did a port scan against hackthisite.org and against the Metasploitable machine on your virtual machine environment. And then we talked about vulnerability scanning, the third step in our hacking methodology. So first we identified the IP address, second we identified the open ports and running services, and then third we identified the vulnerabilities on these services using the Nessus vulnerability scanning tool. We picked 2 vulnerabilities from the Nessus scanning tool, one vulnerability with a weak password and another one with the remote code execution vulnerability. The first one was super easy to exploit. All we needed was a piece of software that helps us connect to the service, and using the password we were able to log in remotely to the target machine. The second one was a little bit more complicated and a little bit more fancy. And for that, we used the Metasploit framework, which has thousands of exploits readily available in it. We picked the exploit that worked for us and we use it to gain remote access over the target machine. So with that, we covered the 4 stages of hacking. We identified the IP address, we identified the exposed running services, we identified the vulnerabilities on these services, and last but definitely not least, we exploited these vulnerabilities to take remote control over our target machine. So there's a lot of ground that you covered, so many different concepts that you learned, And for hanging in there, I would like to say congratulations. Now you might be wondering what's next for me. And to answer this question, I want to take you back to one of the very first slides. The Hackers Academy way of learning. First, you learn and master the foundations. Second, you practice, practice, practice. Third, you share knowledge. And four, you learn some more. Now that you've learned the foundations, it's time for you to practice a little bit more. Go and redo these exercises. Make sure that you understand each and every single one of your missions, that you've completed your missions. And remember to record your success, because once you submit the report, once you submit all the screenshots and the outputs from your missions, there's a very valuable prize waiting for you. So practice, practice, practice. Hang out on the Hackers Academy forum and share your knowledge. Answer questions that your fellow students have. Share some of the discoveries you made. Maybe you learned a new technique. Maybe you found a new tool. Make sure you share this with your fellow students. And then, once you're very comfortable with all that, it's time for you to learn some more. Go to the Hackers Academy training page. Find out what other courses might interest you. I would suggest one of two courses. If you want to learn more about Linux, we have the Linux for Hackers course. Or if you want to dive more into ethical hacking and penetration testing, we have the Professional Penetration Testing course ready for you. But do note though that the Professional Penetration Testing course is a very challenging course. It's not an easy course. It's 4 or 5 days of continuous hands-on practical learning that teaches you how to become a professional ethical hacker. So pick one of the courses that you find yourself interested in. Get in touch with us, ask us about these courses and how you can enroll in them, and get on your way onto becoming a professional expert ethical hacker. I look forward to hearing soon from you, and until then, happy hacking.